Hey everybody, this is Larry. This is day 23 of the March Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you're thinking, let me know how you're doing, and all that good stuff. And today's problem is booking calculator. Okay, so you can multiply the number on 2 or subtract 1. Okay. X and Y can be really big, so you have to be careful, though. You should only need to double not that many amount of time. Let's think about it. I feel like this was a problem we've seen recently, but in another variation. I think let's see. So there are a couple of things that I like to play around with, and I would also say that breadth first search is maybe too slow. No. At least the naive version of it. One thing that I'm thinking of, just like, okay, let's say we can multiply by 2 and then keep on multiply by 2 and then subtract 1, right? But you may have some like weird thing like this one where you may double and then decrement and then double, so that's not super good. And then another thing that I always think about when I see problems like this is see if I can go backwards, right? So instead of going from 2 to 3 or 3 to 10, you go from 10 to 3. And in that case, obviously, you just divide it by 2 and then you add. And I think one thing that I am also trying to prove to myself is that, and also one thing in general is that sometimes these examples are definitely meant to mislead you. And what I mean by that is that, yeah, you can double, decrement, and double, but you could also decrement, double, double, or something like that, right? You could. Maybe not for this case, but decrement, double, maybe not. Maybe I'm lying on this one, but what I mean is just don't trust the example to give you. Trust it to give you the right answer and the optimal answer, but the explanation may be misleading. Is what I'm saying. And in this case, I would say 5, and then. Let's say you go to 5, right, from target. I think it's easier to go backwards for the reason that your search space is smaller, because every time because it's very clear. Is that true? Maybe not. I feel like this is a weird like math problem. I mean, like I also feel like the code's gonna be like 5 lines of code or something like that, or 10 lines of code or whatever. But yeah, so let's say 10, we go to 5. I think there is some math in which it makes sense, but 5, well, you can, there's no, so you have to add 1. So you get 6 and then you subtract, you go to 3. I mean, this one maybe makes sense, but I don't know if that's always going to be the case. Well, so we go backwards, then now we have divided by 2 and add 1. So then here, we can, I guess the math is easier, right? Because for 8, to go to 5, well, let's say we have x and y, right? Let's say 2 times x is greater than y. And we're going from y to x, say. Well, in this case, it always makes sense to divide by 2, right? Just because, well, it takes one operation, and even if x is 1 or something, it doesn't matter, right? Like, this is just easier to do, right? So this is the case where greedy makes sense. Let's say 2 times x is greater equal to y. Well, obviously, in this case, you just take the half and then you get to x, so that also is a good idea. But what if you have 2 times x is greater than y, right? Then what happens? Well, what happens is that you have just one math calculation, right? You have x plus some constant c is equal to y, or you have x, plus well, I think I didn't explain this part clearly, so let me step back a second. So the reason why you always want to go half is because then now you can get the question of whether you want to go half again on the smaller one. And that will be optimal because by definition, you can write this as x plus x is equal to y. or less than y, and obviously if you take x operations on the other side, because this will take x operations, which is way more than one operation, even if it's equal to 1, right? And then you could do it again, and you could do some math about repeat doublings or something like that. So I think now, and this is, I think I have the idea, but now I'm trying to prove it, right? And then now, let's say this is the case. That means that x plus c is equal to y. That means that you only have two ways you can do it, right? You either you subtract c, it takes c operations, right? Or you do something like you x divided by 2, which takes one operation. Is that right? Maybe I'm wrong on this one. No, because then you have, yeah, and then you do the math on that, I guess. Maybe that's the answer. I don't think I did a great job explaining. This is very mathematical, and like, I think for you to prove, you just have to list out all the cases. I think I'm a little bit shaky today because I'm a little bit tired. My apologies for my viewers at home. But definitely, I think it is just listing out every possible case and then prove to yourself that that is the optimal case. So let me play around that, right? So operation, whoops. So let's just say count is equal to 0, and then while target yeah. Oh, also if your current target, meaning you're going backwards, if it's odd, then you have to add 1 because, well, you have to add 1 because let me think about this for a second. Hang on. Well, because you can't get to target without doubling and then subtracting, right? So yeah. I would say though, another way of thinking about it is, I think, is that true? Maybe that's not true. Because if you want to go to 9, for example, how would you go? Go to 6? No, you go 2, 4, 8. I don't know. That's awkward. Okay, fine. Yes, this one is kind of tricky to explain, but the reason why, all right, let's just do start value is, well, I guess just less than, right? So if the target, if this is odd, right, what happens? Well, that means that you have to double the previous time, right? So that means we add 1, we half, and then count, we increment by 2. And then else target and then now your answer should be count, obviously, but then the difference between the count. And in this case, we guarantee that the target is smaller than start value. So then start value minus target. I think that's roughly right. I think my explanation is terrible though, because these mathematical problems are a little bit tricky. But the idea is that if you have one operation, you always want it to be halving, because you want to get the target to be smaller than the starting value, so then you can add to it. So then you're basically getting the optimal starting value. Yeah, I think this is one of those funky problems. This is greedy as hell, but it's also hard to bring to explain. I'm trying to think about a better way to explain it, but it's just that I think if you list out all the cases, the path to a proof is that you can almost always prove that well, you can only increase by doubling, and you want to do the doubling the latest as possible to get it as accurately as possible. Otherwise, you're going to overshoot, right? So then the idea is, if you could double, or if you could increment and then double, or double and then increment, you want to get the one that is closest to the target, and the target is always going to be the one where you increment decrement and then double, because that is going to be closer, assuming that they're both greater than the target, just by definition, because otherwise you're adding 2 instead of adding 1, so it gives you more precision and so forth. I don't know. This is a great explanation. Let me know what you think in the answers on the comments. It seems like the last time I did it, I also spent a long time trying to prove to myself. How did I do it last time? Yeah, I don't know. I don't know how to explain this one. I did the same thing last time, I guess. Except for that, actually my last code was cleaner, but I don't know. Let me know what you think. I think the idea is also, if you look at it backwards, you want target to be the biggest value that is smaller than starting value, and then in that case, having it as early as possible gives you that possibility. I don't know. Anyway, of course, if you look at this code, though, in terms of analysis, even though I don't think my explanation is great, my apologies. Come back, or go to the Discord and ask someone. But this is going to be linear time. Linear being, of course, the number of bits into the input, and the number of bits is going to be log n, and of course you divide by 2 every time, pretty much, or every other. Well, in this case, the way that we write it this time is that you divide it by 2 every time. So this is going to be at most linear time, or 1 operation per bit. In terms of space, I guess you could say the same thing technically as linear space, because that is the size of the input. Cool. That's all I have for today. Let me know what you think. Stay good, stay healthy, to good mental health. I'll see you later, and take care. Bye bye.